Welcome, class. If you're planning a career in business, you're going to face one question over and over again. How can we do this better, faster, and most importantly, cheaper? Well, today we're going to unlock a powerful mathematical secret to answering that very question. We're going to see how a simple U-shaped curve, what we call a quadratic function, becomes one of the most essential tools in any manager's toolkit. Now, I want to be clear, this isn't just abstract math for a textbook. This is the actual blueprint for making smarter, data-driven decisions that can save a company a fortune.
So here's our game plan. We're going to tackle this just like a real business consultant would. First, we'll define the problem that literally every business has to deal with. Then, and this is the really cool part, we'll translate that messy real-world problem into a clean mathematical model. From there, we'll find the lowest point on our cost curve, the sweet spot, and finally, we'll talk about how to turn that one single number into a powerful strategic business decision. Let's dive in.
All right, I want you to put yourselves in the shoes of an operations manager. It doesn't matter if you're running a small coffee shop or a massive factory for a company like Tesla. You are facing the exact same production puzzle. If you make too little, you're not efficient, and you're leaving money on the table. But if you make too much, your costs for things like overtime, warehousing, and even waste, they just spiral out of control. Somewhere in the middle, there is a perfect number, a point of maximal efficiency. The big question is, how on earth do you find it? And here's what's so incredible about this. The answer isn't based on a gut feeling or just looking at what you did last year. It is a precise, calculable number. This is the moment we move from pure guesswork into real strategy. And mathematics gives us the key that turns this really complex business puzzle into an equation that, as you'll see, is surprisingly simple to solve. So, how do we get started? Well, you don't start with a calculator. You start with a model. Now, think of a mathematical model as a kind of simplified blueprint of the real world. It's designed to strip away all the random noise and just capture the essential relationships. In our case, that's the relationship between the number of things you produce and how much it costs to produce them. This is our first major step as analysts, translating the messy, chaotic reality of a factory floor into a clean, elegant equation. And the specific model we're going to use is called a quadratic cost function. What's just amazing about this function is how perfectly it mimics what actually happens in the real world. Think about it. When you first start ramping up production, things actually get cheaper per unit, right? You're buying materials in bulk, your team is getting into a rhythm. That's called economies of scale. But if you push it too far, things start to get complicated. You're paying people overtime, machines start to break down from overuse, your logistics become a nightmare, and your costs start to climb again. This reality, costs going down and then going back up, is perfectly described by this U-shaped curve, which we call a parabola.
Okay, let's get our hands dirty with a real-world case study. Here it is, our company's cost function. The C of X represents our total cost, and X is just the number of units we're producing. Now, I want you to look at this, and don't just see a jumble of numbers and letters. Every single term in this equation tells a crucial part of the story of how this business actually operates.
Let's break this down. First, you see that 200? That's your fixed cost. You have to pay that no matter what. The lights have to be on, you gotta pay rent, your salary employees get paid even if you produce 0 units that month. Now look at the middle term, negative 10x. This is the good news. That negative sign is so important. It means that for every unit X you produce, at least initially, your costs actually decrease. This is your efficiency gain. But then, you see that last term, the plus 0.01x squared? That's the villain of our story. And notice that the x is squared. That's the key. It means that as your production x gets bigger and bigger, this term grows exponentially. It represents all those headaches of scaling up, the overtime, the breakdowns, the complexity. This is the term that inevitably bends our cost curve back upwards.
So, we have our model. We have the story of our business told in the language of math. We know the costs go down and then they come back up. So now we get to the billion-dollar question. Where exactly is the bottom of that U? Where is that sweet spot that gives us the absolute rock-bottom minimum cost? Let's figure it out. And this right here is the fundamental insight. That lowest point on the curve, the technical term for it is the vertex. It isn't just some abstract geometric point. For us, as business managers, it represents the holy grail. It is the exact production level that will result in the lowest possible cost. So our mission becomes very simple. We need to find the coordinates of that vertex. And to find it, we don't need to do any complicated calculus or advanced math. All we need is this, the vertex formula.
Now, it looks incredibly simple, but don't let that fool you. This little equation is one of the most powerful tools in applied mathematics. It's specifically designed to find the x-coordinate of the vertex for any parabola. And for our business problem, that x value is exactly what we're looking for, the optimal number of units to produce.
The process is a simple, repeatable, three-step plan. You identify your variables, you substitute them into the formula, and you solve. And we have to be absolutely rigorous here. In the classroom, if you make a small calculation mistake, you might lose a few points on an exam. In the boardroom, that exact same mistake, a misplaced decimal point, a forgotten negative sign, that could lead to a decision that costs the company millions of dollars. Precision is absolutely everything. All right, the theory portion is over. It's time to put this powerful tool to work on our actual cost function. Let's move from the abstract world of x's and y's to a concrete, actionable number. Let's go ahead and calculate that sweet spot.
Okay, step 1, identify. For clarity, I've just mentally rearranged our original equation to match that standard ax squared plus bx plus c format. It just makes it easier to see our variables. So a is the number, or the coefficient next to x squared. In our case, that's 0.01. And b is the number next to x, which, and please be very careful here, is -10. Forgetting that negative sign is probably the most common mistake students make. Now for step 2, substitute. We carefully plug our values into our formula, x equals -b over 2a. And I want everyone to just stop right here, look closely. This is the single most common place to make an error. The formula itself has a negative sign out front, and our b value is also negative. That gives us a double negative in the numerator, -10. If you miss that detail, your entire calculation will be wrong, and you'll recommend the company produce a completely incorrect number of units. It's a small detail, but it is absolutely critical.
So now we just simplify. That double negative in the numerator becomes a +10. In the denominator, 2 times 0.01 gives us 0.02. So our big, scary-looking problem has now become a really straightforward division. 10 divided by 2/100. And when you do the math, 10 divided by 0.02 is exactly 500. And there it is. That's our magic number. After all of that modeling and analysis, we have our target. To operate at peak efficiency, to achieve the absolute minimum cost, this company needs to produce exactly 500 units. Okay, so we have a number, 500. But as a business leader, a number by itself is pretty much useless. The most important part of this entire process is this final step, translating that number into a real strategic decision. What do we actually do with the number 500? This number becomes your entire strategy. This means you can now walk into that boardroom not with a vague idea or a gut feeling, but with a data-proven recommendation. You can stand there and say with total confidence, our production target needs to be 500 units per cycle, not 480, not 520. The mathematical model proves that 500 is the precise point where we achieve maximum efficiency. That is an unbelievably powerful position to be in. And this really is what I want you to take away from our entire discussion today. When your decisions are backed by this kind of quantitative analysis, they are defensible, they are precise, and they are powerful. You're no longer just managing, you are actively optimizing. You're not just competing in the market, you are finding a mathematical edge over your competition. And that is the ultimate competitive advantage. But of course, as we all know, the business world never stands still. Our model is a perfect snapshot of the business today. But what happens tomorrow when a new supply chain issue causes the cost of your raw materials to spike? Well, that would change the coefficients in our equation. Our sweet spot of 500 would no longer be correct. And that leads us to the final thought. How do we build models that are dynamic? How do we keep them alive and responsive to a constantly changing world? That ability to adapt your model, that is the next step on your journey to truly mastering business strategy.